Great, thank you. Well, thank you so much for having me as well. Hopefully everyone can hear me okay. And sorry, because I think my chair is a bit squeaky, so apologies for that if it kind of interrupts me during the talk. Yeah, so today I'm talking about textual complexity and how it's in the eye of the beholder. So I'm going to start off talking about what text complexity kind of is and the different areas that look at text complexity. Then I'm going to talk about the specific areas that I work on and hopefully provide some motivation as to why I think that this is a really important and worthwhile kind of topic to study. And then I've got two kind of pieces of work that I'm going to discuss and then should take all in all about 40 minutes. So to start off with, what is text complexity? So there's loads of different avenues of research that look at text complexity. Here are some of them. So, people have looked at text complexity from the perspective of human processing, so eye tracking or methods of kind of seeing how long it takes people to process different aspects of text. There's also pedagogy, which is kind of educational appliances for how can you help people to learn, how can you help people to kind of, diversify their vocabulary. Also language acquisition. So there's a lot of kind of studies on child language acquisition and also if you're a non-native speaker, how do you actually acquire language? And the two topics that I work on in particular are readability and text simplification. So these are much more kind of applied areas of text complexity. But in reality, all of these different areas kind of interlink and they all influence one another. So it kind of looks more like, this is the kind of picture that's going on there. And as I said, for me in particular, I work on readability and text simplification. So I'll explain how these two in particular relate to one another. So if you look at these two sentences, the top one says, temperature rises resulting from unchecked climate change will beat the severe end of those projected, according to a new scientific study. And in the bottom example, a new scientific study, the screen thing's in my way. A new scientific study says that global warming might make temperatures rise more than people think. So readability, the top kind of level of readability is that you're assigning a level to a piece of text which implies how easy that text is to actually read. There's loads of different frameworks that you can use for this. You can use levels or you can use kind of like rankings. So if we had two levels, advanced and elementary, we might assign these two sentences with these levels because the top one is a kind of more complex, difficult to read for a variety of reasons. And the way that text simplification actually comes into this is that text simplification is all about how can we automatically rewrite text to make it easier to read and make it more accessible. So this is kind of how readability and text simplification kind of tie into one another. And personally, I think that this is a really worthwhile area to kind of look at from an NLP perspective and from an application perspective. And I'll provide some motivation for that. So in the UK, 7.1 million adults can be described as functionally illiterate. And that means for those individuals, they kind of have a level at or below that of an expected 11-year-old, and that impacts all of the areas of life for those people. This isn't just something that applies to adults. So we also know 1 in 5 15-year-olds in the UK don't have a minimum level of literacy proficiency. And this impacts all of the areas of their educational life because obviously, not being proficient at being able to read can have huge kind of ramifications. And I think one of the things that makes this quite pernicious is that there's a real stigma attached to being able to read. So a lot of people, especially adults, aren't very, they're not going to admit that they can't read because there's a shame. And this is actually a quote from a BBC News article, which is all about the shame felt by people who struggle with reading and writing. So it says, I found it easier to hide my illiteracy rather than pluck up the courage to ask for help. And this is really common. And I think part of what I've aimed to do in the PhD is look at how can we actually build tools that will empower readers, especially because in this day and age we have this really unique opportunity now where a lot of reading takes place on devices, so smartphones, Kindles, laptops, and this has kind of taken this place of traditional paper-based formats. And this means that we can adapt text and we can really reason about how someone is interacting with text and what that tells us about the likelihood that they actually understand what they're reading. So this is kind of, in a nutshell, what I sort of orientated my PhD towards. So I'm going to start off talking about text simplification and a couple of things that I worked on early in the PhD. And then I'll finish off with some stuff that I've done on readability, and how I would like to tie them together. So, okay, text simplification. So text simplification really refers to the process of reducing the complexity of a text whilst preserving the meaning and the grammaticality. There's loads of different ways that you can do text simplification. There's, word simplification, syntactic simplification, conceptual simplification. And primarily in my PhD, I've looked more at word simplification. So one of the things that we know about word simplification is that it's really useful for non-native speakers, especially learners, because non-native speakers should know around 95% of the vocabulary in a text in order to understand it. And that's actually quite surprisingly high, but this study kind of showed that that was the right level of amount of words you need to know. So lexical simplification, there's a long history of people looking at this, and really it's been broken down into 3 main steps. So the first step is something that's referred to as complex word identification. This is literally where you're looking at and identifying the words in the text that someone might find difficult to read or would find, complicated. So in this example, we can see the word treacherous has been highlighted as like a potentially difficult word. And then the second step is you have this step of substitute generation. So you're trying to generate substitutes, and at this point, you can either kind of rank the substitutes or you can filter them based on a set of criteria. And once you've done this, then you found like the set of substitutes that you think would be good, like a good fit for that word. You then perform this substitution step. So you can see in this example, we've identified the complex word, we found a good substitute, and now it's been substituted and the sentence is simpler. And this was really where I started off my PhD. So the first paper that I ever published, big moment, was at ACL in 2018, and it was this paper, Complex Word Identification as a Sequence Labelling Task. So you can see this example sentence up here. So this is output from the system, and it's identified a range of different words as complex. So my reasoning with this paper, the reason we wanted it kind of models is in this sequence labelling way, is that a lot of researchers looked at, okay, fundamentally, what makes a word difficult, what makes a word complicated. And some of the things that come out are the frequency of the word, the context of the word, how it's been used, and also the kind of general word length. So in this first paper, I used a BILSTM architecture, so that it looks at every single word when it makes the decision about whether it's difficult or not. It looks at the left and the right context, and it also looks at word and character level representation. So the morphology, does it have an unusual morphology? And then there was also this joint language modelling objective that predicts essentially the surprisal. So how likely is it that the word would occur in context? And this works very well in a general case in terms of like actually identifying words that might be seen as complex. And then following on from this first paper, I had a second one at NLP, and this is called recursive context-aware lexical simplification, quite a mouthful. And this is the output here. So you can see quite a few of the words that have been identified as complex have been simplified. Some of them in blue haven't, because there's not always an appropriate substitute for a word. So this was kind of at the beginning of the PhD, looked at these like ways of identifying complex words, ways of simplifying them. And so you can see here, there's a variety of different words that have been identified. But one of the things that I started to think is that actually, in a general case, this works quite well. But some of the reasons why these words have been identified as complicated is quite different. So it could be because they're low frequency words, but it could be because they've been used in a kind of metaphorical context. So you can see here, yawning. Part of the reason that has been identified as complex is probably because, it's unusual to use that in the context, and because it's been used in a kind of metaphorical way to mean like wide. And so it really got me thinking, actually, the question, like, who are we simplifying for? because whilst this system works quite well, there's clearly different audiences are going to need different types of simplifications, and different audiences are going to have different needs for what they might find particularly complicated. And actually, one of the things that you notice in a lot of text simplification papers is there's this standard kind of preamble of all the different audiences that benefit from text simplification. So people with low literacy skills and children and people with autism. But clearly the needs of these subgroups really do vary. And these are like examples of papers that have looked into what are the specific strategies for these types of audiences. So I was really thinking about this from a word simplification perspective. How can we adapt? Because the good thing with the previous two papers is that they're quite easy to adapt, because at the point that you identify the complex words, you have a freedom there of deciding what is complex. And at the point of actually generating the substitutes, you can think about, okay, who is this actually for, and which substitutes would be best. And so I, in particular, was very interested in non-native speakers, and especially in how can we build kind of educational apps that would help pick up more language. So it's not necessarily, a lot of this work, it isn't necessarily about bringing the level down to like a base level. It's about helping people bring their level up by understanding what it is that they might find difficult in the first place. So that kind of leads me on to this first kind of chunk of work that I'm going to talk about. Word complexities in the eye of the beholder. So this was work with Catherine Koshmar, Syed Umam and Chris Bierman. And this paper has just been accepted to NACL, so I was very happy about that. And so this paper was really motivated by, I wanted to understand, are there differences, and does it kind of matter whether you're a native or a non-native speaker in terms of what words you might find difficult? So, lexical complexity is a highly subjective notion. The words that I find difficult will be different to the words that you find difficult. There's so many factors that can influence this. Even the particular domain that you study will mean that you have exposure to different sets of vocabulary. And whilst this is kind of an intuitive hypothesis, I would say, there wasn't much on this from like a machine learning perspective. So the main aim of this piece of work was to investigate what aspects kind of contribute to this notion of lexical, like word complexity in native and non-native speakers of English. And for non-native speakers of English, does your level actually have an impact on what you would find difficult? And in order to investigate this, we used this data set, which was this complex word data set, which was collected by one of my co-authors, Syed, and it was actually used in the 2018 Complex Word Identification Shared Task. And this dataset has got annotations for word complexity from native and non-native speakers of English. And there are around 35,000 words that were annotated in total. So an example here, you can see the word flexed. So every sentence was actually annotated by 10 native and 10 non-native speakers of English. So for this word flexed, you can see 7 out of 10 native speakers found this complex, and 9 out of 10 non-native. So this is considered like quite a complicated word in the context. However, one thing that wasn't released with this dataset was that there are actually annotations for the non-native audience, which were these self-reported kind of proficiency labels. So over 2,000 words were annotated by beginners, over 5,000 for intermediate and advanced. And with this paper, we release these annotations as well. So if people are interested in kind of looking into this further, the annotations have been released with this paper. So we've got this data set. It's got words that have been annotated as complex or not by a range of different audiences. And the first question that we had, so there's kind of 4 questions that we look at in this paper. First one is, to what extent can the annotations of one subgroup predict the needs of another? Because it's a nice hypothesis to say that, word complexity is this idiosyncratic kind of thing, but ultimately, if they can kind of predict the needs sufficiently well, then it's not too big of an issue. And the way that I looked at this was, I said there was a shared task in 2018. So our system actually won that shared task. So this was how I ended up getting into the whole space, actually, because I did this for my MPhil. So we had this winning shared task system. It performed really, really well on this data, and it was not a neural model. It was like a feature-based approach, and it had like a range of different features. It had 30 features in total, and these features were really, inspired by past literature on complexity. So we've got like psycholinguistic aspects of word complexity. We've got the syntactic aspects of complexity, word frequency, all these different features. And then we had it in this kind of like ensemble-based system. So because this system was the best system, and I think was still state of the art, we thought it would be good to kind of stick with this. And also, really, we wanted to look at whether these features had any bearing on whether particular audiences would find a word complex. And so to answer this question, to what extent can the annotations of one subgroup predict the needs of another, what we did was we trained the system, very simple, train the system with the annotations of one subgroup, and then saw how it performed when predicting the needs of other subgroups. So to start off with, we just split it between native and non-native. So the first thing that you find is that the best results are, first of all, with the actual group. And you can see that when you actually test, when you train with native data and test on non-native, you don't perform as well as when you actually train with non-native. So that was like the first kind of preliminary test to see, does this actually make any impact? And then we did the same for this kind of beginner, intermediate and advanced. Now you'll notice that the F scores are lower here, but it's because we actually had to cap the annotations at just over 2,000 because we had to kind of control for the size of the set of the beginner annotations. And also all of these results are with 5-fold cross-validation. So the F scores are lower, but the pattern still remains. So it's always the case that when you're predicting for a particular group, it's best, the results are best when you actually train with annotations of that group, which makes sense. And but it was good to kind of prove this out and show this actually empirically. We also then looked at if you actually train with native annotations, how does it perform when predicting for beginner, intermediate and advanced? And we found that actually the native annotations perform best when predicting the needs of advanced, which kind of makes sense. And there's actually quite a marked difference there if you look at how well it performs. And this was actually a pattern that really emerged throughout the work. We kept seeing that it's kind of like the concept of word complexity from a beginner as you move up to advanced becomes more similar to that of a native speaker. So that was quite interesting to look into too. So that was question one. To what extent can the annotations kind of predict the needs of one another? Sometimes to an okay degree, but it's always best if you can actually, model using the annotations of the subgroup to begin with. So that was question one. Question two, is there a difference in feature correlation depending on subgroup? So we wanted to know whether, in particular for native and non-native, so as I said, every single sentence was annotated by 10 native and 10 non-native. And we wanted to look at whether the absolute number of annotations correlated with these features, because we've got all these different types of features, to kind of give an indication of what really is important, or kind of what is most likely to cause a word to be seen as complex by these audiences. So we would have really liked to do this for the beginner, intermediate and advanced, but the problem was it wasn't held consistent, the number of annotators against all of the different sentences, so we couldn't do it. But with the native and non-native groups, we found that, well, there was three kind of findings that I think were interesting. The first one was that the correlations for the native class were higher. And this isn't surprising because in the native class, the first language has been controlled for. One thing that I'm really interested in looking into, and it would have been nice to look into it here, but we didn't have the kind of demographic information, is the extent to which first language actually impacts your view of complexity, because subsequent work that I've done shows that there's quite a significant effect there. So the correlations are higher for this native class, but it will probably be because that L1 has actually been controlled for. This was, so I think this is quite interesting. So historically, when you look at word complexity and you look at the literature on word complexity, three of the kind of features that are always again and again brought up are word length, word frequency, and then like psycholinguistic features or factors. But actually what we found is that frequency, whilst it was in the top 10, it didn't appear in the top 5, but this KF-CAT feature did. So KF-CAT is, well, I'll explain first of all, the reason why frequency is very informative for word complexity is because ultimately it's a proxy for how likely it is that you will have encountered that word before. So if there's a highly frequent word, it's likely that you'd have seen it before. So it's kind of less, you'd have had more exposure, so you'd find it less complex, or you probably know what it means. Whereas, so this KF-CAT it's very much about word specificity. So what this represents is, if you look at all the different genres of text, so like biological text, literature, maths, this is a count of how many different genres a word appears in, so kind of like the specificity of the word. So there's an example here, altimeter. That's highly specific to like a geography, like context, I think. And this has actually a very low like KF-CAT number, whereas other words, appear. So for instance, grounds, that's a word that appears in a lot of different genres of text. Now, obviously, this is correlated with frequency, but when you actually control for the frequency, this effect is even more pronounced. And I think this is interesting for a couple of reasons. One, I mean, it's not really talked about much with respect to word complexity, but it's come out as one of the most correlated features for both of these different groups. But second of all, because one thing that I think is interesting is domain-specific text simplification. So I think a lot of the time people assume, when you talk about text simplification, you might think, well, that's for people who are at a low level. But I think actually one way that text simplification is very applicable to a lot of people is when you're looking at cross-domain literature. So I think this is kind of an interesting finding. And it correlates more than frequency. So that was quite surprising, actually. And then the final thing, looking at this, so if you look actually between the two, a lot of them are actually very similar. These kind of very, you've got the length, you've got this KF-CAT, and you've got aspects of psycholinguistic aspects as well. However, in the native class, the number of syllables correlates much more highly. In fact, in the non-native class, this doesn't even come into the top half of features. And that's actually quite a distinct difference between these two. And we were thinking part of the reason for this is that when you look into the research on, people processing when they read, lower skill readers with lower vocabulary sets tend to have phonological representations that aren't yet formed. So there's something about the way that a native speaker is reading this, maybe out loud in their head, that means that they're taking into consideration the syllables more than a non-native speaker. So that was actually another kind of interesting finding. So I think to conclude, like that sort of question, largely, a lot of these are quite similar, but the syllables was one that came out as a bit different between these two classes. And then the third question was, okay, we've looked into, the fact that some of these features are quite similar in terms of how important they are. So if the features that are important are similar, then is it actually the range of features that vary depending on the audience? Because if these models are performing differently depending on which set of annotations you train them on, what is the kind of difference that's going on there? And in order to look at this, I plotted some histograms. So I looked at the three kind of main areas that I said before that have been looked into from a complexity perspective: a word length, frequency, and imageability. And for people who don't know what imageability is, this is like a psycholinguistic aspect, which is how easy is it to associate the word with an image. So for instance, basketball, you can picture a basketball, so that's got like a high imageability, whereas jealousy, kind of hard to picture that in a kind of concrete way. And so first of all, I mean, some of the findings from this, beginners more shorter words are found as complex, more high frequency words are found as complex, and more high imageability words. And there was quite a difference actually in the distribution of features for this particular group for beginners. And it's interesting because when you look at actually advanced speakers, there's a narrower range of frequency, and it's almost like there's a taxonomy or kind of hierarchy, depending on the level that you're at, as to what you would pay attention to. With beginners in particular, because the kind of decoding strategies aren't as good as advanced, it seems to be that there's quite a lot of factors that can impact whether it's seen as complex. Whereas for an advanced reader, it's more generally whether you've been exposed to that word or not. So, you know, if it's a really kind of low frequency word like altimeter, you know, that might be difficult because it's just the fact that you haven't seen it before, as opposed to anything deeper going on there. So that was interesting. And then we also see this kind of pattern where the relative relationships between beginner and advanced is very, very similar to that between generally native and non-native. So again, we see this pattern where this concept of word complexity tends to like converge and become more similar to a non-native, more similar to a native speaker as someone becomes more proficient. So that was okay. Why is this interesting? Like, why do we care? So I think there's two reasons why. If we know, for instance, that for advanced non-native speakers, that there's a narrow kind of band of frequencies such that it's unlikely they would have seen the word before, it really helps us when we do constrained text generation. And actually a lot of these insights, like if we know that, for instance, for a beginner group, there's a set of frequencies that they're definitely, you know, unlikely to have seen, and then that moves for advanced and moves more to the right for you know, native, then it means at the point of generating text, we can actually constrain for words within a particular frequency. So you can see at the bottom here, there's like this bubbles where you can see, you know, the kind of higher frequency words are bigger. And so, you know, you would be able to actually constrain your model to be able to stay within those frequencies of words. And another reason why this is important is that, generally speaking, you can do, you know, you can train LSTMs to do very complex, ironically, like complex word detection. Or one of the simpler ways that you can do this is actually something called informed thresholding, or just thresholding. So you can say, okay, everything that is below a certain frequency, I'm going to assume is complex for this audience. And it's just kind of a more informed, heuristic way of being able to reason about readability, which a lot of readability systems don't actually have, because they tend to have this like one size fits all and don't really take into account how this can vary for the different audiences. So then the last question in this paper, do these models better capture readability for different audiences? So we were quite keen to kind of look at this in more of a downstream way. And we looked at readability. So as I said, readability is where you're assigning a level to a piece of text. And we use this dataset Newsella, which has got text at 3 different levels. So the way Newsella's set up is that it's been simplified. So they have an advanced text, they simplify it to an intermediate version and an elementary version. And this is to train kind of readability or text simplification systems. And so what we wanted to look at was, if we take the model, the complex word model trained with beginner annotations, and we take the complex word model that's trained with advanced annotations, how does that perform on these kind of different levels of text? And there's 2 things that we see. The first thing, for both models, they find more complex words in the more difficult versions of the text. So that's good. That kind of sanity checks that actually, you know, it is finding more complex words in things that have got a higher level. And the other thing that we can see here is that actually the beginner model consistently finds more words complex than the advanced model. And again, intuitively, this makes sense, because if you're a beginner, it's likely that you're going to find, you know, more of the words complicated. So this is quite a nice finding. And I think, again, this really does show that if you're considering readability, or even if you're considering kind of text simplification, there's many more words that this beginner model is finding, you know, potentially as complex for that audience than for the advanced. So that was kind of the downstream like sanity check that these sort of models were working in the way that we would expect them to. So I think that was the final question for this paper. Yeah. So complexity, it's a subjective phenomenon and it's dependent on the intended audience. It's intuitive. I think, no one would argue with that as a premise, but I think this paper really goes to try and actually prove that empirically. So we show that the best models for a target proficiency are trained with the labels of that subgroup. The best performing features and the distribution of these kind of classic complexity features really do depend on the target audience. And audience-specific models kind of perform more realistically on these downstream tasks. So they were kind of like the main things that we looked at in that paper. And as I said, the data set will be released for this. Also, we'll get this on archive as well so people can look in more detail, because I think it's quite high level for this talk. But yeah, so that was all kind of, that's where we were at with the text simplification stuff. So I've looked at how to identify complex words, how to simplify them, how you can reason about which words might be complex. And then this is kind of the second part. I will say, so I've got a paper and review on this that I can't really talk about, which is a shame because it's like the big bulk of work on this. So this is very high level. It's just kind of talking about the study and also some of the findings, like preliminary high level findings. Also, I'd like to point out that I photoshopped this phone into the hand of this brain, and I was very proud of myself for that. Okay, the main aims of this study. So this study was done with Tony Mackey, Jenny Burzak and Matt Sharifi, so MIT and Google. And the main point of this was like investigating how on-device reading strategies vary across audiences. And the way that we look into this is we did this 600 participant study. And at high level, there were kind of three elements to this study. So the first one, participants are presented with text at different readability levels. So we only focus on two levels. We focus on advanced text and kind of elementary. As the users read, as the participants read the text, we measure a bunch of interactions, which I'll explain which interactions we measure. And then finally, once they've read the text, they're then asked a set of comprehension questions. So they get presented with two texts randomly. One's more difficult than the other, and they answer some questions after each text that they've read. And the data set that we used for this was One Stop QA, which was based on a data set called One Stop, and this was collected by Jenny. And this data set is quite good because it has a range of questions with it, and the way that it's been designed is such that it's very difficult to actually answer the questions if you haven't read the text, so you can't really guess them. So you can see part of the reason for this is they have these distractor spans in them. So for instance, here you can see this name. So if you superficially kind of engage with the text, you might see this name and think that that's the answer. But actually they're quite clever questions because they're designed to not be guessable. And for the 600 participants that took part in the study, we collected demographic information for them. And you can see here, just a sanity check, we were quite pleased because this self-reported proficiency did, show that the mean scores kind of showed a nice pattern there. So you can see beginners getting less of the questions right on average, and then it goes up all the way to kind of native. So the interaction measures that we looked at were scrolling measures. So we looked at kind of like the speed, the average speed of reading, the minimum and maximum speed of reading, the acceleration, how many times someone would pause when they were reading. So you can see here on the right, this shows someone kind of scrolling through. And also the number of regressions. So this was kind of inspired by eye tracking research. And this is essentially, as someone's reading, if they scroll back up to recover an area of the text, we count the number of times that they do that. So those were the different interaction measures that we looked at. And the first question really that we were looking at is, do reading interactions actually vary depending on the difficulty of the text? So on average, if people are presented with text that's more difficult, does it vary? How do the reading strategies vary? And we looked at this in a variety of different ways. One of the ways that we looked at this was we used linear mixed effects models to kind of look at the difference between these interactions based on the difficulty of the text. And we found that there were quite a few interactions that did statistically significantly vary depending on whether you were looking at easier text or harder text. So for instance, the average scroll speed, which is really almost a proxy to like how long it's taking you to process the text as you read. So we found that it did differ. And we've run like a ton of experiments on this. We've also found that you can predict the readability of text from these aggregate user interactions alone, which is actually quite an interesting finding because all traditional kind of readability systems use features of the text, so text length, but you can predict readability looking at these aggregate interactions. And we've also found that you can really improve state-of-the-art models on readability by incorporating this information as well. So that was a good finding. And then the second thing that we were really looking into was, do reading interactions vary depending on the score that people get? So ultimately the score is a proxy to how well someone's actually either understood the text or engaged with the text, because some people might not have read it or might have just flicked through. So we wanted to know, can you judge how likely it is someone has actually understood what they've been reading based off how they're interacting with it? And again, we found multiple interactions did correlate significantly with this score. One of them, again, is like average scroll speed. So there's almost like a Goldilocks effect, where it's like if someone's reading too fast, then they're not paying attention, or if someone's reading too slow, they're probably finding it quite difficult. And there's like a middle ground where actually it's likely that they've read and understood the text. And here you can see like a histogram with the different scores, and you can see that there's different distributions there, different spread of speeds. And also we did kind of like some TSNE plots, and you can see that there's in the top right there, this TSNE plot is all of the different interaction measures, and we just kind of group them together, plot this, and then if you colour it by score, it's quite nice because you see in the top right there's this group forming of like very high scores, and then all the way down to this band at the bottom where people haven't scored as well. There's loads of other things in this work that I think is really interesting. Something that I'm very interested in is how first language can impact this, and we see that there's very different reading strategies depending on first language. We also see as well that at the point that someone is answering questions, you can tell the proficiency based on the kind of confidence with which they can navigate to the area of text, which I think is really interesting too. So yeah, there's loads of stuff on this. Future work. So you can see, obviously, I've done this work on text simplification, word simplification, and also on device readability. So can you tell the extent to which someone is understanding something as they read, or how difficult text is based off different interactions? And I think what I'd really like to do going forward, like for the kind of next year and a bit of my PhD, is how can you combine these so that you have this level of subjective readability where you can look at how someone is actually interacting with text, and also, ask them what their kind of background is. And based off that, either perform text simplification as they read, or one thing that I'm really interested and keen on is the idea of kind of scaffolding text. So instead of trying to change the text, adding in annotations to help someone, scaffold them in. And really part of this as well is helping people have the confidence to try and read text that previously they might get put off by because it's at too high of a level, and increase accessibility that way. I know I've absolutely just bombed through that, so I'm sure there'll be some questions. I want to say a big thank you to all of my collaborators. I also wanted to plug the fact that we have got a text simplification Slack group. That's been really, really good for finding new work and finding people who are interested in text simplification and just complexity generally. So I started that group at ACL in 2018, and I think I've kind of spoke about it at every conference since, but it would be really great to get some more people on that. And also, I mean, so that is actually a link, but I can share these slides. I'll probably tweet about them and then people can find it that way. And yeah, I talk about a lot of my work on Twitter, so feel free to follow me there. And thanks very much. And if there's any questions, I'd be very happy to take them.